Okay, this is the question number 5. Evaluate the integral by converting to polar coordinate. And this is the integral. Double integral. Okay, now let's try to understand the region. The first layer of the integration was the x, and this expression are x values. So the first one, x equal y, is a line bisect first quadrant, third quadrant, and the second is x equal square root 2 minus y squared. If you square both sides to understand much better, it's 2 minus y squared, x squared plus y squared equal to. This is a circle. It's a circle with the radius radical 2. This is approximately, here, radical 2. It's a circle. But this is the half of circle, quarter of circle, or the entire circle. Let me see. The integration was doing in this direction, from this to this, from y equal x to the y corresponding with the positive part of the circle. Okay, it's so obvious. You see, this is the positive x corresponding with the right semi-plane, so x positive. Okay, this was the direction of the integration. Integration with respect to x first, integration with respect to y second. Okay. But I need to determine that point. That point is when the y is equal x. See, y is equal x in this equation, entonces x squared plus x squared, because y is equal x, equal to 2x squared equal to x is equal, square is equal 2 over 2 get 1, x is equal plus or minus 1. Actually, it's only positive because the region is this. Entonces, this point, I suppose que es the point 1, 1. This is my region. And this is the direction for the integration. Okay, one student or somebody do this integral. Set up this integral. My goal is convert to polar. Okay. Conversion to polar now. Okay, when you convert to polar, double integral in polar, the integral function is x plus y. You cannot leave it like that. You can change x is equal r cosine theta plus another r sine theta. This is y. The differential in double integral is r dr d theta. Multiplication everything by r dr d theta. And the limit. The limit in this region, r go from 0 to radical 2. And theta go from 0 to pi over 4, because this is 1 over 1. 0 pi over 4. Ready. Let's compute it now by hand. This is there. Well, in this case, you can multiplication. R times r is r squared. So and you can perfectly apply the property for the double integral, in which you can separate the cosine and sine part, and the limit is a constant, into completely independent integrals. So you set out one integral from 0 pi over 4 that includes only theta function, the theta. You are aware that you can do that this because, let me show you in detail. This is r squared cosine theta plus sine theta. It's a big parenthesis. this r squared come from r times r, r times r. And this is multiplication, and you can separate cosine theta plus sine theta separately times another integral from 0 radical 2 the r squared dr. Okay, good. Okay, let's focus in this integral. Okay, the antiderivative cosine is sine. The antiderivative sine is minus cosine, and you evaluate in between 0 and pi by 4. Entonces, sine pi by 4 minus cosine pi by 4 minus sine 0 minus cosine 0. This is radical 2 over 2. This is the same value. Therefore, that part is 0. It's going to 0. Sine 0 is 0. Cosine 0 is 1. And double negative becomes positive. And the answer for the first integral is just 1. The answer for the second is super easy. The antiderivative is r cubic divided by 3. Evaluate between 0 and radical 2. 0 is 0. And radical 2 is radical 2 cubic over 3. And radical 2 cubic is radical 2 times radical 2 times radical 2, and radical 2 times radical 2 is 2. And the answer is 2 radical 2 over 3. That's the final answer. Super.